Hi everyone, this is question number 5 from the 2008 AP Physics B free response questions. You can see the AP website for the question itself or the scoring details. Let me just read it out loud. A 0.03 mole sample of helium is taken through the cycle shown in the diagram above. The temperature of state A is 400 Kelvin. A. For each process in the cycle, indicate in the table below whether the quantities W, Q, and delta U are positive, negative, or zero. W is the work done on the helium sample. B. Explain your response for the signs of the quantities for process A to B. Calculate volume of C. So the first law of thermodynamics is delta U equals delta Q plus W. Delta U is the change in internal molecular energy. Delta Q is the change in heat supplied. And W is the work done on the system. In this question is the helium sample. Okay, so then I want to look at the PV graph. So there are 4 types of different thermodynamic processes. The first is the isothermal process. Iso means same, thermo means temperature. So in an isothermal one, delta T is equal to 0. And also, the change in internal molecular energy, since delta T is 0, cannot increase or decrease, so delta U is also 0. In this graph, the area under the curve is equal to the work. So this was the first one. The second one is the isobaric process. In an isobaric process, the pressure is constant, so delta P equals 0. The third one is the isochoric process. Here, delta V is equal to 0. And since the work here is, we can find the work, but here it is equal to 0. Because there is no area under the curve. The fourth one is a little bit different. It looks similar to the isothermal one, but it's much steeper. It's called adiabatic. Here, the delta Q, so the change in heat supplied is 0. And it's a very quick process where there is excellent insulation of the system. Okay, so I want to tackle my question now. For each process in this cycle, so from A to C, it's isobaric. From C to A. From B to C, it's an isotherm. Usually because these two are too similar, the AP people will indicate what it is. A to B, it's isochoric. Okay, so in this process, in process A to B, it's isochoric. I already said the work is 0 because there is no area under the curve. The Q, let me just write this equation. Delta U equals delta Q plus W. So W is 0. U is equal to 3 over 2 nRT. This is my formula for U. Since the V is constant and the P is increasing, what would happen to the temperature? It would also increase. So when this increases, the delta U will also increase. So in the end, I'll have both delta U and delta Q increasing, so they will both be positive. From B to C, I see an isothermal process. Delta U is equal to 0. When delta U is equal to 0, I can say 0 is equal to delta Q plus W. PV is constant. So here in this graph from B to C, the pressure is decreasing and the volume is increasing. So usually when pressure is decreasing and volume is increasing, it should be that the temperature is increasing too. But in this case, the temperature stays the same because it's isothermal, so somehow the system is keeping its heat. So there is a heat that's supplied that is positive to compensate for this negative work done. So work is negative and Q is positive. From C to A, it takes the isobaric path. In an isobaric process, I can write the ideal gas law, PV equals nRT. In here, delta P is 0, so P is constant. V is decreasing, and then N is the same, R is the same, so T should also decrease. And when T decreases, I can say that delta U, which is directly proportional to T, also decreases, so delta U is negative. If I am to write the formula for delta Q, it's NC delta T. These two are constant, and since the temperature decreases, delta Q will also decrease, and therefore it is negative. The work done from C to A is then positive. So okay, part A is complete. Explain your response for the signs of the quantities for process A to B. A to B was the isochoric one. Okay, so my first response was that the work is equal to 0. For this, I can just say no area under the curve, which was equal to work. So W is equal to 0 because there is no volume change here. And since W is equal to negative P delta V, I can say it's equal to 0. I mean, this can have like many answers. It can also indicate delta V is equal to 0, but this answer would be acceptable. And then for the Q, I said it's positive because for a fixed number of moles in the sample, an increase in pressure when the volume is constant will make an increase in temperature, and an increase in temperature makes an increase in internal energy. So let me just say a fixed number of moles, and then P increases, V constant. This means, if you just pressurize something when the V is constant and the P increases, this means an increase in temperature. And an increase in temperature implies an increase in internal energy. When what was internal energy? It's delta U. From A to B, delta U is positive because when temperature increases and volume is constant, heat must be added to the system. So here I saw that there is an increase in temperature. I can just repeat it again. Okay, so this answer would do. C asked me the volume for C. PV equals nRT. We all know this. This is the ideal gas law. So using the ideal gas law, I can see that N and R are the same from all these processes. So I can just work with these three variables. And then I can work with B and C because it's an isotherm. I can also get rid of this. So they're the same temperature. I can just say PB VB is equal to PC VC. So working from here is much easier. And then I can leave VC alone by saying PB over PC times VB is equal to VC. And then I can just put in my variables. And my answer for VC is 0.005 meters cubed.